The purpose for this video is to document the construction of this breakout board, and the results were considered satisfactory. Another goal was to mount this integrated circuit. It's a 16-bit analog to digital converter that has 24 I/O pins. The first attempt failed due to insufficient temperature. The second attempt may have been successful based on some initial tests, but more testing is required. This solder template was modified with Scotch tape, which resulted in too much solder paste. What follows now is a quick overview of all the components in this project. A reflow oven was constructed. A welding blanket was used to insulate it. A 25 amp solid-state relay activated the 120 volt AC quartz heating elements. A large heatsink protected the relay. A controller named Tiny was implemented. Worked well on another project, but not this one, due to the low temperature limitation of the integrated circuit. An aluminum enclosure external to the oven was selected to house the controller. An Arduino was used to replace Tiny. A thermocouple and instrumentation amplifier provided the temperature sensor for the Arduino. Here's the instrumentation amplifier. A gain of 2703 was implemented with an external resistor. Filter caps reduced noise. Multi-sim and multiboard were used to design the printed circuit board. Transfer film was used to transfer laser printer toner to the single-sided circuit board. A heat press was used to transfer toner from the transfer paper to the copper circuit board. Ferric chloride was used to etch the copper circuit board. A microscope, tweezers, dental pick were all essential in this project. This plexiglass template with a cutout the size of the integrated circuit, it was laser cut. The goal was to drop the integrated circuit through the template after the solder paste was applied. The final integrated circuit alignment was not satisfactory. Here's the early version of the oven that shows a few components. There's the first temperature controller named Tiny, and a heat sink and solid-state relay. Welding blanket provided some insulation. This 5-volt adapter for Tiny has a transformer, not a switching regulator. Welding blanket on top and both sides. Welding blanket on the back. Welding blanket was doubled, including the bottom. A double pole, double throw switch was included, which provided multiple ways to control temperature. Aluminum tape from Home Depot was used to seal the door, easy to open and reseal. Aluminum enclosure blocked line of sight to the heating elements. Arduino program controls temperature rate. That's a power supply for the instrumentation amplifier. And that's the instrumentation amplifier. Three thermocouples mounted very close to the circuit board with aluminum tape. The most reliable way to know the reflow temperature is to observe the paste turning to solder. The low temperature paste reflows at 138 degrees C. Digital thermometer for one of the thermocouples. The current monitor was always less than 10 amps. Noise and at input and output of the instrumentation amplifier. It's 2 millivolts peak to peak at the input and 5 volts peak to peak at the output. And that's the relay on-off signal. This probe monitors solid-state relay on-off. Tiny was used to monitor temperature. Arduino was used to control the temperature. One goal was to build the breakout board for this integrated circuit. Maximum temperature was 150 degrees C. Solder paste reflows at 138 degrees C. Integrated circuit placement accuracy was 1/8 of a millimeter. It was not achieved. This is the profile for the low temperature solder recommended by the manufacturer, and here are the test results. 100 seconds more warm-up time was required. Arduino measured 91 degrees C. 90 degrees C was the goal at 190 seconds. The 3 thermocouples were a few millimeters from the circuit board. Reflow was observed at 138 degrees C based on the solder drops. However, the thermocouples measured 150 degrees C at reflow. The measured rate is noisy, but the controller does a fair job of controlling temperature. Conclusions. Much experience was gained in all phases of this project. Reflow oven worked well. Breakout board was constructed. Our chemical etching procedure was marginal due to small trace separation requirements. The solder paste stencil had to be modified. Manual integrated circuit placement may have been sufficient. Solder reflow temperature and maximum IC temperature were very close. Initial testing indicated possible success, but more testing is required in order to examine all features of this integrated circuit.